Just before we dive back into the episode, I wanted to quickly share something that might interest you, especially if today's conversation has got you thinking about your own sustainability work. Some of the things we hear most in this industry are, I wish I could connect with other people doing this work, or I'd love to turn my sustainability expertise into something more. Well, 51 to Carbon Zero, the sponsor of this podcast, have created their own referral network. And it does exactly that. This isn't about selling you something, it's actually about helping you make money while building the sustainability community we all need. So here's what's in it for you. First, you get to join a genuine community of sustainability experts who share knowledge, refer work to each other, and solve problems together. So, no more working in isolation. Secondly, there's real money involved. There's 10% plus commission on software referrals. We're talking about projects that go from 30 grand up to 100 grand. Plus, you'll be able to boost your presence by taking part in our fireside chats. I've actually got an email in front of me from Louise Stevens, one of the ambassadors, and it says that all her clients are genuinely happy because she's got a great partner and her clients love them. But here's the bigger picture. You'll be helping accelerate the sustainability transition that we all desperately need. Every referral, every connection, every collaboration moves us closer to the world we're all working towards. If this resonates with you, and you want to earn some extra income, click the link in our show notes to become a 51 to Carbon Zero ambassador. Okay, back to the show. Hi and welcome to Sustainability Solved. I'm Will Richardson, the founder and CEO of the Green Element Group, incorporating Green Element, Compare Your Footprint, and of course Sustainability Solved. We've been empowering organisations to manage their environmental impacts for a just and sustainable world since 2004.
And I'm Charlie Luxton. I run a sustainable architecture practice. In today's episode, we're talking about beer. And in particular, we'll be finding out why fossilised algae plays a big part in producing beer and how we can move away from it in the future.
We're joined today from Berlin by Dr. Roland Paul-Dobrik from Filtration. Welcome to the podcast, Roland.
Good morning. Welcome. Thanks for having me.
So, Roland, you spent your whole career working in the brewing industry. Now, can you tell us what the fundamental sustainability issues are that the industry is facing? Because I assume water usage is a big one, production of crops is a big one, transportation is a big one. But are there other elements and areas that you're tackling?
You are very right. I mean, you named a few of the very important ones already. Water, obviously, when you produce a liquid beverage, but it's basically all of those challenges that the industry today has. It's electricity consumption, it's heat energy consumption. It's also being efficient with the raw materials that we are using. That means modern day production equipment is something that helps brewers a huge deal to be more efficient on all of those things. Where water consumption in the past decades has dropped by factors like 4 or 5 to make it very efficient these days. That's where the circle comes back to me, where a modern filtration solution that is more efficient than the conventional technology is, for example, able to add another saving of 30-40% in the water consumption just by changing the technology that you are using to filter beer, just as an example.
Could you just do us a favour, Roland, and just very briefly run through the process? I mean, I've been to a couple of brewery tours, but I think if you haven't, it's really worth understanding just the very basics of the process and where the key sort of environmental challenges are within that sort of linear chain.
Right. I mean, beer brewing starts by choosing raw materials that can be made fermentable. That means they need to be rich in starch. And those that are rich in starch are typically necessary of being broken down to fermentable sugars. That's something that the brewer does in the brew house. That means those raw materials are going to be mixed with water. And then natural enzymes, some people also add enzymes, are breaking down the large molecules to smaller ones, for example, the starch into sugars. And then later on, the process will involve, for example, a boiling step where hop is added. And later on then, when you cool that down, it's going to be fermented. Yeast is going to ferment the sugars to produce alcohol and CO2 and a lot of aroma substances at the side. And then after that, in by far the most volume shares out there, like more than 90% of the beer is going to be filtered to make it stable to be sold in retail. And after the filtration, which is something that I specialize in these days, it's going to be packaged and then brought into retail. And of course, it starts with the production of the raw materials to be brewed with and later on fermented. That needs to be efficient. The brewer then has the responsibility to extract efficiently. The processes will always be accompanied with a lot of cleaning since we're producing a foodstuff, of course. And in every step, you're, for example, also facing the challenge of loss. We call that beer loss. And you can improve that, of course, also when you go for modern day production equipment. This goes through and through. And one of the challenges that is specifically interesting to me these days is that the conventional technology that dominates beer filtration these days produces a lot of waste. When we are using something that we call Diatomaceous Earth, often abbreviated as DE, in other countries it's called Kieselguhr, it's exactly the same stuff, and that's being used for filtration. This adds up a lot of waste to the beer production. When brewers use, for example, and that's already a good number, 100 gram of DE powder on 100 liters of beer. You know that brewers calculate in hectoliters. So we always reference everything to a hectoliter. And if you use 100 gram of that as a dry, pure powder, it's going to produce around 300 grams of waste on every hectoliter. Large breweries produce millions of hectoliters per year. That means these are hundreds of tons of solid waste that are produced by the brewery. And that's, of course, something where you can also, if you're able to get rid of that waste stream, you can make a significant impact on the sustainability of the brewing process.
So you're stirring this DE, this diatomaceous earth, into the beer, and that sort of stops the fermentation process. And I assume it sort of sucks up some of the various proteins and stuff that's in the beer to stop that process and make it stable. And then you strain that out, and that produces an enormous amount of bio waste, I'm assuming. So you've got lots of different kinds of waste products mixed in with that DE. And that's basically waste at that point. There's no other use for that material?
Hardly any. I mean, when you start to look at the DE itself, it's fossil algae. Those are dismantled from the ground. They are then purified and heat treated, and then they are brought into the brewery to be used. Chemically seen, it's sand-like, it's silicon oxide basically, but since it is fossil algae, it has a huge inner surface due to bizarre shapes that it has, and that's what makes it applicable for filtration. And then you are very right, it adds a lot of organic material to it that is filtered away from the beer, like yeast, like proteins, very much as you said it. And that makes it very difficult to reuse it. You would have to wash it. You would have to remove all the organics completely. And then if you did that, technically possible, of course, but then you have a mixture of all the sizes of DE particles, which makes it basically impossible for the brewer to reuse it again, because the technology, of course, being relatively complex, needs to have different particle sizes of the DE to properly run. And that's why almost nobody in the world out there really reuses their DE. It has been in trial status, and there might be the one or the other prototype, but in large scale, it's not economically possible to really reuse the DE powder for the filtration.
So this is fossilized algae?
Yes.
Sort of in a sort of limestone-esque type form?
Correct, yes. And it's almost pure silica oxide, but it can, of course, it's a natural developing process. It can contain metal, for example, which poses another challenge for the brewer, because that can leach into the product and have certain impacts, yeah.
With that waste, you hear about other food or beverage production facilities you're able to use the waste as kind of slurry or others, that's absolutely not possible in this situation.
Well, there are opportunities to reuse it, for example, as a soil improvement. I hope that's the right word. You can use it in farming. It's not actually a fertilizer because it doesn't meet all the criteria a fertilizer needs to have, but it can be used as a soil improvement, but only to very small rates. And that means that typically the brewer is not able to find somebody being able to use up all the DE waste that they produce. So most of it typically goes into landfill. And there, in some countries of the world, it's actually considered hazardous waste because the dry powder is hazardous when inhaled. So operators working with the DE need to wear personal protection equipment, or you need air suction infiltration and some stuff. It's absolutely not harmful if swallowed and ingested. So even if trace particles would reach to the final customer, no problem. But if it could be inhaled, then it poses a health risk. And that makes it not possible to simply throw it out there into the environment, because it might be a powder that is then blown away with the wind again. And also this high concentration of organic load also makes it something you need to control when you're getting rid of it.
Do all breweries use DE?
Very good question. Not all of them. I just said it's the dominating technology, and it still is, but there is a trend these days for the brewing industry to move away from that, not only because of sustainability issues, but this is one of the biggest impacts, really. And the alternative to that is something that, for example, the company I work for, Paul Filtration, is bringing into the market, which is membrane-based filtration, where the membranes can be reused. That means you wash the membranes and then you can reuse them for the next filtration again. And that, of course, has a big impact on the waste accumulation. You can find literature values of more than 50% waste reduction. Actually, it's much more. If you follow the process as Paul is running it, it's way above 90% waste reduction. But also things like the CO2 footprint that, of course, has been calculated. And there you find values of between 20 and 40% improvement for the CO2 footprint of the beer filtration when you change away from DE into membrane filtration. So this modern type of technology, as many modern technologies, of course, goes and tackles those challenges and tries to bring an improvement on these specific points of interest.
And when you've got your big membrane and you've scooped out all the biomatter and all of this organic matter that you want to get out of the beer, does that then become a more usable product? Because one assumes that has uses. Again, as you say, soil improvement or biogas as well. I imagine you could use that for energy generation.
Yes, you're right. I mean, when you use membranes instead of DE, you don't have the DE waste as such anymore, but the only waste that then occurs is basically the organic matter that you're filtering away. And you are right, there are certain ways of reusing that, biogas being one of them. And there are also technologies that try and regain as much as possible beer from this solid matter that you're not using in the final beer. For example, there are also filtration technologies to filter the spent yeast. Huge numbers of beer actually in the waste yeast. If the brewers don't do anything about it, it can be like 2 to 3 and even more % of the total output of a brewery. That is beer in the waste yeast if you don't do anything about it. And there are filtration technologies that enable you to recapture like 80 to 90% of that. And that's also something that brewers gladly hop on these days because that improves the efficiency largely. And that in terms of sustainability is, of course, raw materials efficiency, and that makes the whole process more sustainable.
It seems to me that cost-wise, DE must be more expensive than this membrane technology, forgetting about the sustainability. So it sounds like it's a bit of a no-brainer. Why aren't people going down the membrane route? Full stop. It's better for the environment. It's cheaper. It's easier. It's got, you can get rid of the waste more easily. Everything is in its favor.
You are right. Actually, it is like that, only that, of course, we have to acknowledge that modern type technology, sophisticated technology, is, of course, something that costs its price to invest into. Everybody in the industry always separates capex from opex. That means investment cost from running cost. And the running costs, according to everything you just summed up, are very much in favor of the membrane filtration. The investment cost is something where the more modern technology, of course, is slightly more expensive, and that needs to be paid back over the time followed by the OPEX advantage you're generating. And the other thing is that we're talking about solid steel production machines. That means brewers that did buy DE filters, say, 10 years ago or something, they still look into using them for another 10 or 15 years even. And that is, of course, investment where investment planning is necessary and everything, so that it's not something where you really switch from one to the other. It's like if you have a car that uses up a lot of petrol, you're not going to change the next day to another car because you want to save on petrol because the car is expensive. So these are the kinds of considerations that, of course, slow the process down. But your summary was very right. And that is why many brewers are following that technology. And it's not a secret that many of the large brewers out there already made strategic decisions to move away from certain production technologies where DE filtration is one, for example, where they made plans to not go investing into that kind of technology in the future anymore, but go for alternatives where membrane filtration is pretty much the only viable out there.
And how much do you think that's been driven by reduced production costs and reduced waste issues? And how much of that is being driven by the fact that they feel they can produce a more sustainable product and market it as a more sustainable product? I mean, is that an element of the beer industry that people are actually starting to think about? Like, I want to get a beer that has as least impact on the planet as possible. I mean, are we seeing that on cans? I can't say that I necessarily have.
These are so many great questions in one, and I need to pay attention that I don't start lecturing. But
oh, go ahead, go on. That's what we want. That's what we've got you for.
No, it's great. Starting with the end of what you just asked, actually, I've seen examples in Sweden, for example, where people make beer festivals where they advertise their beers with the CO2 footprint from the beer production, and then you can actually choose your beer according to the CO2 footprint. Also, and that's where we really get the connection back to what I'm doing, also, most of the brewers these days follow sustainability programs. The big ones, very strict sustainable programs that they also publish regularly about, because they, of course, need to follow legislation. Legislation is getting more strict on industry being more sustainable. Smaller companies, of course, need to follow up with the performance of the big ones and try to follow them also. And the good thing is, for the initial part of your question, is it more cost saving or is it sustainability? It's actually both. Of course, it's cost saving as well. But the good thing is, when you want to become more sustainable and you save on water, that saves money and you become more efficient. If you save energy, that saves money and you become more efficient. So it very much goes hand in hand, but it's not only that people want to save money and then say, look how sustainable I am, but they really have very ambitious sustainability programs, the big ones all, and most of the small ones, because they are driven by legislation and they understand that this is something that appeals to the customer, specifically the younger generation. They will be watching very closely who does what in terms of sustainability in production.
Because it's an interesting one, isn't it? Because you're talking about one section of this long production sort of system, I suppose. Where are the other big challenges that the beer industry are facing? I mean, because climate change and drought is radically changing, radically impacting agriculture. Is this something that the beer industry is tackling? And if so, how?
The brewing industry tackles that. Again, if you look for what the big brewing groups are doing, they very often also have programs to support the farmers that produce their raw materials to make sustainable farming, organic farming possible and stuff like that. But it's also inside of the breweries where people have become much more aware of being raw materials efficient. You said it, I think, in the very beginning. All my professional, almost all my adult life, I spent in beer brewing and beer consumption, of course, at the side. But when I started working in a brewery 32 years ago, of course, there was not that much awareness about having product loss. But people were really, okay, yeah, that's beer that's running down the drain. But these days, everybody is trying to cut on their losses very much, not only because it's more efficient, but it's also going to help them being more raw materials efficient. And coming back to the examples I stand for these days, when you are able to disrupt a technology and improve the beer losses in that step by, say, 40, 50%, that's already helping a lot. Another thing that I did mention is that we have technologies with which you can recover almost all the beer that would go with the waste yeast into whatever other application. That helps to be raw materials efficient. So there is a lot of that mind change these days in breweries. And that's, of course, something that we weave into the technologies that we're offering, because we know that our customers are going to pay a lot of attention to that. And we need to satisfy that need that they have to be more efficient, but also save on raw materials that they are using.
Just before we dive back into the episode, I wanted to quickly share something that might interest you, especially if today's conversation has got you thinking about your own sustainability work. Some of the things we hear most in this industry are, I wish I could connect with other people doing this work, or I'd love to turn my sustainability expertise into something more. Well, Green Element, the sponsor of this podcast, have created their own ambassador network. And it does exactly that. This isn't about selling you something, it's actually about helping you make money while building the sustainability community we all need. So, here's what's in it for you. First, you get to join a genuine community of sustainability experts who share knowledge, refer work to each other, and solve problems together, so no more working in isolation. Secondly, there's real money involved. There's a 10% commission on software referrals and 5% on consultancy work. We're talking about projects that go from £1,000 right up to 100 grand. Plus, you'll be able to boost your presence by taking part in our fireside chats. I've actually got an email in front of me from Louise Stevens, one of the ambassadors, and it says that all her clients are genuinely happy because she's got a great partner and her clients love them. But here's the bigger picture. You'll be helping accelerate the sustainability transition that we desperately need. Every referral, every connection, every collaboration moves us closer to the world we're all working towards. If this resonates with you and you want to earn some extra income, click the link in our show notes to apply to become a Green Element ambassador. Okay, back to the show.
So if you were to say, here's the question. You might not have the answer. Let's say there's a litre, and I'll use a litre because 2 pints or a litre of beer. What would be like an old-fashioned sort of CO2 emissions associated and water usage for that, and a modern, efficient beer production? Are we talking like a magnitude different of water and energy use, or are we talking half? And how much progress have we made?
There was a lot of progress being made. The DE-free filtration has been published to be 20 to 40% more CO2 efficient than conventional DE filtration is. So that's a CO2 footprint reduction that is published, and that is a measured factor out there. When it comes to water, it's a very, very good surveyed sort of KPI. That means a factor that everybody is following. When I started working in the brewery, it was a solid 10 to 8 liters of water used per 1 liter of beer. That's 3 decades ago. These days, the best in class use 2 liters water per liter of beer. So that is a huge saving. It's a huge saving. And that is, of course, something where modern day production equipment comes in. I love to use the example of dishwashing because everybody can relate to that at home. If you wash your dishes at home, if you wash your plates with a running tap of water, you're going to use a huge lot of more water per plate than you would use if you use a modern dishwasher that even has an eco program where the water is recycled, where resting steps, avoid high temperature steps, and so on and so on. And here again, if we stick with my example, where DE-free technology saves around, say, 30 to 40% of the water. If you go a step further into the production, where people these days look very much into trying to avoid pasteurization for the sake of avoiding heat usage, that is also something that you can replace with filtration technology. There, the savings can be up to 70 to 80%.
So rather than boiling and pasteurizing the water to make it into liquor, you filter it and avoid that entire...
Excuse me, I need to be more precise about that, I guess. No, I was speaking about pasteurizing the final product, and there you wouldn't boil it.
Okay, yeah,
You wouldn't boil it, but you would use temperatures in the range of 60 to 70 degrees and something, and there you can make significant replacement by filtering the product instead of pasteurizing it. And there, the saving potential is huge also, very much as it is when you replace the DE technology with the membrane filtration technology.
With that statistic, 1 to 2, and then 1 to 8, 1 to 10, you're almost getting to the point where you could drink beer instead of water, like the Victorians. It's brilliant. I love it.
Small beer in the morning, only small beer.
Well, that's what the
morning.
Victorians did, isn't it? They drank beer instead of water because it was cheaper and better.
Well, everyone
wouldn't kill you.
for thousands of years we've done that because it didn't kill you, because it was clean, wasn't
it? It was a source of water that was hardly spoiled. Yeah, that's the point. And that's, by the way, why beer is also a very global phenomenon, right? I mean, as we speak here together, we come from those typical beer countries, right? Everybody has long beer cultures, but beer has been invented probably somewhere completely else, like 10,000 of years ago or something like that. And it's a totally global phenomenon.
I think longer. There was a one of those memes that went around, or it may not be called a meme, but there was the oldest pub in the world was found somewhere in Arabia, and they found, a place in the middle of the desert where people would have gone to drink beer together, and it was literally tens of thousands of years ago they found this archaeological site.
And the beer production these days is split almost completely evenly all over the globe. It's really, if you look into those larger sections of the world, if you split the world into three big sections, almost a perfect third of beer production is in each of those sections. And that is also where our customers are. And all of them these days are thinking into replacing conventional technology with more modern technology to be able to yield those advantages and savings that we're speaking about here.
Well, so you've got upstream food production of crops. So you've got regenerative agriculture, organic agriculture. So you can start to tackle barley production, hops production, yeast production. I know you've got challenges around climate change and shifting growing areas. You're now talking about a significant tackle on the reduction of waste during the actual production process, but you've still got that sort of slight elephant in the room of all of those beer bottles and beer cans and kegs and lorries driving that around.
Right.
What's being done at that final third, which seems to me like probably almost the hardest thing to challenge or to tackle?
You are right. And that's one of the reasons why I skipped the question on the CO2 footprint of beer in total, because the biggest impact typically comes from that part of the production. And it's also not a secret that one of the ways that specifically the brewing industry is going there is lightweighting of packaging material, downgauging. If you use hundreds of millions of crown corks per year, it makes a difference if you lose some bit of a material there. But again, if you allow me to come back, what my center of work these days is into that final third of the production, we're also looking in, for example, replacing heat pasteurization, which can also make a lot of an impact, and using filtration technology there as well. So I am totally with you. There is a lot upstream and downstream of what we as a company stand for. But of course, on all of these aspects, there will be specialists also working on it. And we are working on the filtration steps, making these as efficient as possible.
So that's the pasteurization around kegs and reuse of bottles. Is that the pre-pasteurization before bottling?
The filtration, of course, is something that you would do upstream of bottling, right? It's very difficult to filter the product once it's in a bottle. But that's specifically what I'm speaking about. You're right. But then, of course, there is a lot of reuse of not to say waste streams here as well. I mean, a lot of water, for example, is being used to convey the heat for pasteurization. If you pasteurize cans and bottles, that is done by heating up water and then trickling the water all over those packages. And there again, of course, you can use that water, but you have to make it up again so that it is clean enough to reuse it. And then again, there are options for filtration and other technologies to reuse that kind of a waste stream.
What do you see the big next steps in terms of the sustainability agenda within the brewing industry? Where are the next big gains going to be? What are you working on down the line?
Actually, one of our center points of interest really is to work on that DE replacement, because that is something where Paul Filtration holds a lot of know-how, and where the change into going not using DE technology is just picking up speed. You just mentioned wine. There, the change is already much more complete. Many wine makers have already made the step away from using DE for filtration, going into membrane filtration. But wine filtration is not as challenging from an industrial point of view. Wine filtration is bound to the time of harvest, and it's shorter and smaller batches and so on. And allow me to say, it's also not as sensitive a product, so that it took a little longer. But it took a little longer for the brewing industry to adapt to changing away from DE filtration, and it's now really picking up speed. And as I'm saying, it's a huge industry. We're speaking about 2 billion hectoliters every year of beer that are being produced. And as I'm saying, 90% plus of that is being filtered. So we're speaking about huge volumes that are filtered every day of the week, every hour of the week almost. So the technological challenge to achieve that is a slightly different one. And that's why this is only really picking up speed at the moment, which makes us concentrate on that aspect very much, because we hold that technology that enables that very much.
On the back of that, and what you previously talked about, the barrier to this would be the steel and the equipment that's already in place and the money that's been spent on that. Has any research been done on the life cycle analysis of that steel? So could you take all of that steel and repurpose it? Because steel is worth quite a lot and it can be reused.
You are completely right. That is something that is also picking up speed at the moment. This is also something that we are looking into very much. And we've also experienced our customers asking for something like that. Do you have this life cycle analysis for your equipment and everything? And we're building it up. But of course, when you look at older equipment that is out there in the field already for a while, of course, it hasn't been done for that kind of equipment. So this is also something that will only make its way into the industry, coming in with newer equipment, with more technological sophistication, and with the understanding of sustainability that we have these days.
So I've just been tapping away on my calculator, and I'm sure I've got this wrong, but I'm getting to 54 million tons of waste coming out from the filtration process. If you're right, at 2 billion hectoliters, which is 200 billion liters of beer, right? And you said it produces about 300 grams of waste per bad processes produce about 300 liters of waste at 90%. I get to about 50 million tons of waste globally. Does that seem, am I wrong? Am I got noughts in the wrong place?
You are a bit too quick for me. I didn't do that calculation. But something I am prepared to say is that it's a very simple calculation. If you have a brewery that produces 1 million hectoliter, and that's the brewery of the brand that you love to drink, 1 million hectoliters per year is already a small brewery these days. The really big ones produce 15, 20 million hectoliters a year. So if you use 100 gram of DE on every hectoliter, that makes 100,000 kilograms of dry DE every year for this smaller, middle-sized brewery. And that makes 300 tons of waste every year for a relatively small brewery. And if you do that and scale it up, you might end up with those numbers that you just calculated, which I don't dare on a podcast to say yes or no to because I didn't do the calculation myself. Please.
No, I suspect I'm wrong. It just seems like a lot of numbers, a lot of noughts. I mean, just the millions of hectoliters is like ludicrous amounts of beer. So one question I've got is, how much have the big breweries been challenged by the rise of sort of craft beers and microbreweries? I mean, the sector has seen an unprecedented change over the last 10 years. Have they been driving change, or have they been encouraging conservatism?
That's a good way of putting it. I mean, you obviously also followed the craft beer trend, right? And that promoted very conventional ways of producing. Most typically, that's actually something that was very much put in the forefront of some of the strategies. This, together with craft brewers typically producing smaller batches and many different varieties, makes it very often difficult to be as efficient as a big one for a small brewery. So the big brewers are typically more efficient when you look at the numbers of what they really consume and what their specific consumptions are, like when we speak about the water per beer consumption and everything. So I don't think that the big ones are being driven by the small ones when it comes to being more sustainable. But here, the big ones, I really think, are on the forefront of that because they can be more efficient. It's easier for a bigger one to invest into more modern production equipment and then having the benefits paying back over time. And it's also that the big ones are addressed, of course, by legislation much more than the small ones. But it's very much also the other way around, as we've said before. If there is beer out there that can be produced sustainably, then also the other ones are going to hop on that train. And of course, the craft brewers are doing their best to be sustainable as well. There are many craft brewers out there that have their programs in terms of being CO2 neutral. There is a big one even out there that has a CO2 negative beer out there and things like that. So I wouldn't say one drives the other, but the whole brewing industry moves towards more sustainability.
So that's very interesting. I take a point. There was a moment when my heart was sinking where you were effectively saying I need to go to bigger breweries and stop my sort of slightly sort of love of small craft breweries. But you pulled it round right at the end by saying maybe there are some out there that I can still drink beer from. What about alcohol-free beer? Is that better or worse for the environment?
I can see where that question is coming from because alcohol-free beer is, of course, one of the major trends in brewing these days, and almost every brewery produces one. And alcohol-free beer is much more diverse than the traditional alcohol-containing beer. There are technologies to produce alcohol-free beer that vary greatly. So I don't think that you can generally say it's better or worse in terms of sustainability, but it again will come very much down to the technologies that are being used to produce it. The batch sizes play an important role when it comes to specific consumptions. The one thing that I can say is that, of course, alcohol-free beer has its own very specific challenges of being produced. Like, for example, when we mentioned pasteurization before, alcohol-free beer is, of course, more susceptible to microbiological spoilage. So you have to pay more attention to that kind of a quality of the beer. And here again, also modern production equipment offers a lot of advantage. And brewers are very wise if they pick carefully what kind of technology they want to use for that production. Because very much as you're saying, you cannot have alcohol-free beer being much less sustainable. So you also have to be very much looking out to what kind of technology you want to use to produce it. To make a summary of that very long answer, I don't think you can say it's more or less sustainable, but brewers have to pay very close attention to the kind of technology that they're using.
So that's a relief. I don't have to feel that I need to drink alcohol-free beer from a sustainability perspective necessarily. Thanks, Dr. Roland. That's really helpful.
And finally, we're coming up to Christmas, and we I don't know about people on this, but I do buy beer for the family. We get, you have all the family coming over. In the past, I've always bought Toast Ale because I trust and know the Toast Ale brand. But are there any other brands that you can talk about that you think actually they're really best in class at what it is that they do?
I can say so much. I think I said that all the time, that many brewers pay attention to being more sustainable. The big ones having their strategies and so and that's something where I always say they wouldn't be the big ones if they made bad beer. That's number one. The other thing that a brewer always will answer you is stick to the regional beers. A regional beer will always have a short transportation chain. It will most probably have regional crops that they are using and everything. And it's most typically the most fresh beer that you can have, which also helps a lot. And freshness is a very important
Brilliant.
quality for beer, which we also try to support with our technology.
I love it. Buy local.
Buy local. Brilliant. I live in a village with a very famous brewery, an 1890s tower brewery. So that's great. I can now go down to the village shop and get some of
It's such
the
an
local
amazing
beer.
brewery, that.
And that's it for this episode of Sustainability Solved, the Sustainable Business Podcast. Thank you very much to Roland Powell-Dobrik from Pool Filtration. I'm Charlie Luxton.
And I'm Will Richardson at Green Element. For more information on Green Element and everything we've discussed today, please check the show notes. If you have any feedback or questions, you can get in contact with us at Green Element on social media.
And don't forget to follow this podcast in your favourite app or write us a review. Thanks a lot. See you next month.
So you really enjoy sustainability and want to be a part of the solution? Come and join our vibrant community now. Book a call and we can talk more.